Hello again, Internet peoples. Please note this is a re-release of a video from my old channel, A Digital Mind. As you recall from the last video, we identified a bit of a problem with our object positioning based on its pivot point. So as you can see here, when I move the object around on screen, the pivot point is actually the center of the cube itself. So it doesn't sit flush on our surface. We have a couple of options here that we could use to actually adjust this so the cube then sits on the surface. One of them is that we could actually make an empty game object, and we can then position that where we would like it to sit. So if we reset it, the normals, so it's actually sat flat on the surface itself, and then make our cube a child of that object and ensure it's in the right position. And then instead of moving the cube itself, we make the object that we move that empty game object. And if we now point the mouse at the screen, you'll see that the cube, being a child of that empty game object that sits on the surface, now the cube sits nicely on the plane itself. However, that's not my preferred method. The reason that that isn't my preferred method is that you have to have two game objects for every item that you wish to place. It may add some features like giving us extra control over the item, but I actually prefer to work in code to adjust this. So let's undo the changes we just made. We'll take our cube back out of the actual empty game object, delete the empty game object, go back to our game manager and place that cube back in as the object we're going to be moving. Let's just check that's gone back to how it was. You'll see now that the pivot point is back in the center and we are actually sitting halfway through the plane that we want to place the object on. So looking at our code, we can actually adjust this at runtime with code and how and where we want to position that cube. So transitioning over to Visual Studio, the first thing we need to do is actually create a variable to store the bounds of our object. In other words, the points of the extents of the object, the edges of our object. So to do that, create a bounds variable. We're going to call this cube bounds for simplicity, so we know what it is and we can read it in the code. And then we're going to actually get the object's renderer initially. So to do this, we use the get component function within Unity. Trying to get our renderer, and we want to grab the bounds from the renderer. This is the edges of our object. Now using that, when we're placing the object, we can actually add to our hit point a new vector to align the cube object with the surface. To do this, we add a new vector 3 with an x of 0 because we're not going to be moving to the left or the right. We actually want to move vertically, so we're going to use our cube bounds extents.y because we want the y extent to move it upwards and nothing for our z bounds. Now if we compile that and hit play in Unity itself, we will now see that our object is sitting nicely on the surface of the plane. So now that we have the object sitting nicely on the surface of the plane and acting just like any object, any building does in Islands itself, how do we identify where and where we can't place an object? So the first thing we need to do is actually create a surface that we shouldn't be able to place the object on. So to do that, let's just duplicate our plane and we will move that across a little bit. And we will also then rotate that axis, but we want a negative rotation. Okay, and let's move that object back towards the surface that the cube is sitting on. And as you can see from the game view, it's very difficult to see, so let's just create ourselves a new material. Let's call that blue, and let's make it a shade of blue, and let's drop that on that duplicated plane. So now we can see that there's a surface there at the background that's on an angle. So if we hit play now, we should find that our object will go up that surface and around on the flat surface. So we want to be able to place the objects on the flat surface but not on the angled surface. So how do we do that? So we use a little feature within Unity called the normal of the object, the normal of the hit point. Well, we'll find that if that normal on a Y, i.e. the vertical direction, is 1, we're on a flat surface. If it's not a flat surface, it will be a value other than 1. And we can use that to determine whether our object can be placed on the surface or not. So let's just demonstrate that quickly with an output to our debug console. So let's flick back to our code, and we want to quickly output the value of our normal. So that's our Y normal. Now we hit, quickly build that, transition back into Unity, and run our program. We can see there on the flat surface we have a normal of 1. And as we go up onto the angled surface, our normal changes to a value other than 1. If we go off into our background, it still stays 1 because that's where the object was last pointed to. So now we have detected our normal, and we can see that our normal, how to read our normal and use our normal. Let's transition back into our code. So how are we going to use that? So visually, in Islanders, our object changes to a red. So let's go back to Unity, and that creates ourselves a couple of materials that we can use. So we have a red already, so let's create ourselves a nice material, say orange, and let's change that to a nice shade of orange. We now have 2 materials to place on our object. Let's transition back into our code. And we need to make a few little changes here. So for changing the material of our object, we have to obtain the renderer. So let's create a renderer variable. And we have to get a component from our object. Guess what? The renderer object, the renderer component. We now have our renderer. And so we're not typing things out twice, let's just alter the variable below for the bounds to cube renderer. And there we go. We now have access to our object renderer. And what do we want to do? So When our ray hits the surface of an object, we want to check it's normal to ensure that is equal to 1, i.e. it's a surface that's pointing directly upwards. Okay, and if that is 1, we want to change our material. But to what? We need to create a public variable to place our materials in. So public material can place material and a can't place material. And when we have got a value of 1, we want the can place material. Else, if we haven't got a normal y of 1, we want our can't place material. So if we now build that and transition back into Unity, have a look at our game manager, we now have these 2 new variables to store the materials. So our can place should be orange, our can't place should be red, and now if we run the game, you'll see when we're over the flat surface that's pointing vertically, we have a nice shade of orange, and when we go to our angled surface, it changes to red. However, we're not positioning our object, so we've made a mistake there. So let's transition back to our code. What we actually need to do is move our positioning code to the outside of the normal check. Build that solution again, transition back into Unity, hit run, and now we can see when we hit a surface where we shouldn't be able to place the object, the colour of the object alters. Of course, there's various ways you could use this. This is a very simple example just to show that the change in colour. You could use different shaders. You could even change the object itself. So there's one last thing we're going to cover in this video, and that's what happens if our mouse on screen is pointing to an area that has no object that the Raycast can hit. So this doesn't actually happen in Islanders, because in Islanders you have the water around the islands, so wherever you place your mouse you're always hitting an object, and the object will always move to that point and just show whether it can be placed or can't be placed. For completeness, in this video I would just like to cover a scenario where there isn't anywhere for the object to be placed and what should happen there. In this case, I'm actually going to make the object disappear and then reappear when we're back over a surface that we can place the object. So to do that, let's transition back into our code. It's quite a simple thing. What we need to do is use the actual ability in Unity to set an object to be active or not. So if we are hitting a surface with our Raycast, we want to set the cube to be active. Otherwise, we want to set the cube not to be active. Let's just build that code again and transition back into Unity and hit run. So now we can see that when we're over the surface with the vertical normal, we can place the object. We're on an angled surface, we can't place the object, and we're pointing at nothing, the object disappears. We come back over a surface where we could or can't place an object, and there you go, we can see it again. Okay, thank you for watching this video. If you like the channel, please remember to subscribe. If you like the video, please remember to share it. And check back next time where we'll be looking at other mechanics within Islanders itself. Apologies for the inconsistent sound during this video, as it is a re-release of an old video I produced using old equipment. Thank you for watching.